Okay, good evening, everyone. I'm Judge Chen. Thank you all for joining the webinar. And I'm from Hong Kong University of Science and Technology. Today, I would like to talk about the topic, which is about openBIM over full life cycle. This is a brief introduction about myself. I'm Associate Professor and also BIM Lab Director of Hong Kong UST. I'm also very honored to be the chair of the Hong Kong CIC BIM Standard Task Force and also be involved in a few BIM-related associations like AIAB, the Hong Kong IBIM, etc. So in the following, I would like to share with you some of my views and also my experience about openBIM. And thanks again for the Alliance to give me this opportunity to share with you. In the following, I will give you the presentation in 4 aspects or 4 parts. First of all, because I will talk about openBIM with some examples. So I will first give a recap on what is openBIM standards. Later, then we will talk about some examples of openBIM over full life cycle. And then I will also mention some future developments to give you some update. Later, then we will talk about some challenges from my own point of view. Some buildingSMART standards, the openBIM, some of you may know, some of you may not know, is that it's a list of the open standards by buildingSMART, which used to be called IAI. We have IFC, Industry Foundation Classes, MVD, Model View Definition, IDM, Information Delivery Menu, BCF, BIM Collaboration Format, and bSDD, buildingSMART Data Dictionary. And in the following, I will introduce briefly each of them so that later when we go through the example, then you know what we are talking about. First is IFC. IFC basically is the model of the BIM and the information. So you can see this example. We have IFC wall, we have IFC window, etc. And they also not only define the object, but also define the relationship between them. You also see that they have something called the local placement. Basically, is they have the coordinate system based on the object. The coordinate system of the window will be based on the coordinate system of the wall, which will be called based on the coordinate system of the building. What actually is IFC is a bunch of text. And you can, if you have an IFC file, you can open this one just with a notepad. And when you open it, you will see something like that. You may not need to care about what is inside, but the message is that with IFC, then we don't need to rely on a particular software because even a notepad can get the information inside. So this is what we call the open standard. What you probably need to remember is for IFC, we try to capture the geometry and also the semantic information into this format, the IFC object definition and IFC property. And then we try to link these two together. So this is basically IFC. Another concept is MVD. MVD is model view definition. So we have the B model, the digital model like IFC, but maybe we don't need every piece of the information. So that's why we should create some view and we should have the definition to see which part of the model I will be interested. And then you just send me the relevant information to me. So quote some examples. We have IFC coordination view, we have IFC structure analysis view, IFC thermal analysis view. Basically, is that I have the same BIM model, but for different purposes, for different people, then maybe I need just the right information for me. So this is the view concept. Then we have IDM. IDM basically is the information delivery menus. So there are 2 main concepts for IDM, and later we will also touch on that again. One is the workflow, another is the exchange requirements. Workflow is for IDM, basically is the whole workflow, and then link all the tasks together. And then for each task, then we need to specify who should provide what information at this task and who should receive the information as well. So that's why for IDM, basically is the workflow. and then the exchange requirement for each. So this is one example of IDM. We have this workflow and then the connection with all the tasks. And then we also define what's the information required. And all this information required will be linked to IFC. Fourth is the BCF. BCF is the BIM collaboration format. So basically we have the model, we have analysis, we have quality control, etc. And then all this will be in IFC. But if we have some comments, if we want to have some markup, etc., then we will put this markup as BCF format, so that through BCF, I can have some add-on, or maybe I can link the BIM models together, link the IFC models together. So this is the main purpose of BCF. So for some software like Tekla or the Revit, those are the common BIM software. They also have support the BCF. And you can see that if I want to give some comments, then I can click on an object and then add the comments and then in the BCF formats. And this is open standard because this is still stored in the text format, and then I can retrieve all this BCF information with different kinds of software. The fifth one is bSDD. bSDD is buildingSMART Data Dictionary. This one basically is the list of the terminology or the data dictionary that we will try to capture all the terminology. Okay, so with this one, we can link up the terminology in different languages and in different software as well, like Revit, ArchiCAD, etc. Basically, what is bSDD is for this terminology, then we need to, in this terminology, then we need to link this one with different properties and then for different purposes. So this one basically is try to define the terminologies and then has a so-called dictionary. Okay, and later we will come on this concept again, the dictionary. And so I quickly go through this concept of the open standard by buildingSMART, which is IFC, MVD, IDM, BCF, and bSDD. And if you have attended the training in previous sessions by the other two speakers like David Fong, and then you probably will be have the basic understanding of that. The linkage between these items, maybe, yeah, this one is a little bit messy. Basically, you can consider that we have use cases. So for buildingSMART, they always start with use cases. What's the application? And then with the use cases, then they try to define the workflow and or process map, and then the exchange requirement, and then we get the model, okay, which is in IFC. And then this model, as I mentioned, we don't need every piece of the model, so that's why we have different view and also have the dictionary. So this is how we generate and link these standards together. And why I talk about this one, because when we apply this one for a life cycle, when we try to have different applications through the whole life cycle, basically it's the same. We can have a particular application, which will be the use case, like structural analysis. I will go through this one. If I have maybe solar analysis, I will go through this one. If I have maybe assets management, I will also go through this one. So that's why I mentioned the use cases can be over the assets life cycle. So and for different application, then this is the linkage between all these standards. Some of us may also have heard of one standard called the COBE. This is particular another open standard about facility management. Basically, the concept is how the information of the design and construction can be linked to the facility operators maintenance. And this one is not by buildingSMART, but this is also one open standard that is common, and also I would like to introduce all of you. So very quick walkthrough of the open BIM standard. So in the following, I would like to go through different examples of the full life cycle open BIM. And in particular, I will talk about design, engineering, construction, and facility management. But you can see that the whole concept is we would like to use BIM for the whole life cycle. And we would like to use IFC in particular, okay? But in reality, there's some problems. The architect may have his own model, engineer will have his own model, and the actual building will maybe another look, and then operation model will be another look. So in terms of information, in terms of format, etc., and they may not talk to each other, and this is reality. And that is why we need open standard to link that, okay? But in reality, it may not be that simple. When we talk about linking up all these life cycle stages, there are a few questions we need to think about all this data exchange. One is, how can we formulate this data requirement of different applications? How can we exchange that? How can we combine this data to serve the purpose? How can we retrieve the data to be used? And then how to validate the data and make sure that the data are correct? And how to manage the data so that it still kept quality or consistency. So that's why when we try to link up all these stages, we need to consider all these questions and before we really start the project. And if we try to rely on a particular software, as you can see, it may not be possible to have a single software to finish all the tasks throughout the whole life cycle. So that's why we need multiple software. But when we try to have multiple software, particularly maybe multiple people in the project team, then this is one example that they may not talk to each other, okay? And that's why we need interoperability, meaning that the software should talk to each other. So that's why this is the concept we want to do is, first of all, we should have the requirement and then should go to the design, go to engineering, go to construction, and finally go to asset management or facility management. In the conventional method, you always can see something like this, the red color. When we jump to one stage to another stage, usually we will have information loss because I need to withdraw the model in another software, or maybe I don't have full set of the data, and then I need to recreate something of them again. And then this one is not very promising. So that's why what we want is through the digital workflow or open standard, then we can link up and then we don't have this kind of sit set. So in the following, I will go through them one by one. First of all is design and the requirements. Here, then you can see that we have the requirement definition. This one is an example from Denmark. Basically is if I have different rooms, then we can define different room profile. And then I can assign this room profile to different rooms, okay? And this is what they have developed based on open standard. Sorry that this is not in English. This is in the Denmark language. But you probably can get the concept is that first they try to define the room profile. And then later they will try to assign this room profile to each room. And then they can establish the relationship between them. For example, maybe the room profile A and room profile B should be linked to each other, or maybe they should not be each other, something like that. So with that, then they can assign the room profile, and then all this is a web platform, and all this actually was done in openBIM. Okay, so this is one example about the requirement, and then embed this one to design. And then after we have the architectural design, then we can have the engineering design. Basically is we can perform different kinds of engineering analysis. If you have tried to do some openBIM software for structural analysis, you may have experience of something like this. This is one case in left line. And you can see that this is basically is a BIM model and in Tekla. And then they also can have the analytical model with all the rebars and with all the loading, etc. And then with that, then they need to have the linkage with IFC. So they transfer the BIM model to Tekla through IFC. And then what they have done is they have the design model from Revit, from Tekla, and then they can join this one with the analytical model in RFEM, and then they can try to do different kind of parametric modeling through the Rhino and Grasshopper. They also link this one with the PDF calculation so that they can try to generate different options to see which option is better for the structural perspective. Finally, then they can filter the solutions, and then they can generate a list of the options which they think is the best. But they find out that the challenges of this kind of project is that they need to link the data seamlessly. And also, they find out IFC is not cannot cover all the necessary information. Particularly, they don't have IFC analytical. That means they may only have the geometry, but after analysis, the results cannot be stored fully in the IFC model. They also need to see how to connect the geometry. That means, for example, if the connecting components, if one is moved, then another one should also be updated. And all this should be achieved in IFC. And I think IFC keeps improving to fulfill this kind of requirements. So all these actually are the example of doing using openBIM standard IFC to perform analysis, engineering analysis. Another example that this one you see Hong Kong University logo because this is actually done by us. We try to integrate BIM for different engineering analysis. Basically, we use Revit to draw the model, and then we export to IFC and link it to different software like ETABS for structural analysis, and then we also link it with some CFDs software to perform the analysis of the fluid, and then see the ventilation indoor and outdoor. We also see what's the thermal analysis. So that's why we plug this one with some green building analysis software, something like that. So by doing that, then we can link up multiple software through IFC, through open standard, and then we can perform the optimization of the design so that we can get a low carbon or low energy building design. And this can be achieved if it cannot be achieved by a single software. To link up multiple software, we need to use this kind of interoperability. So these are the examples of BIM standard, open BIM standard for design and engineering. We also then now we move on to construction. In the following, I would like to go through two examples or two actual cases in different parts of the world to go through construction and asset management. So I will talk about one case for construction and one case for asset management in more detail. For construction, we actually will try to consider time and also cost and more. So that's why we have the concept of 60, 70, or starting from 3D, we have 4D, 5D, 60, and 70. You can see that we have the clash detection can be achieved by 3D. Then we have 4D for the constructability analysis. Then we add the cost for estimation, and then we can have the energy or sustainability for 60, and then we have the life cycle, or sometimes it's called safety for 70. And these are the aspect that contractors will be very aware of. So that's why based on the 3D B model, then we can achieve all these. I would like to go through a particular case in Japan about how they use openBIM model to support construction. This is a project with IFC model. So you can see that this actually is an IFC model with all the details like scaffold, the anchor, etc. So they model not only the building itself, but they also model the temporary work in IFC. And then through this one, then they can generate the 4D visualization for the constructability analysis, etc. They also make use of openBIM software for managing issues. And you can see that they try to have one issue, one bubble. And then this one may be a little bit small. You can see that they have a bunch of the bubbles. And then those bubbles will have different colors. For example, it's a new issue or resolved issue, etc. Then have different colors. And then all these bubbles will be placed in different zones. And through this one, then they can manage different kinds of the complaints or the inspection, etc., or maybe the change order, something like that, in the digital model. They also use the BIM model as the base for supporting construction logistics. Basically, they want to link the construction site with the headquarters and with the supplier. And you can see that they can use the BIM model as the base to link up all three, and then link up all the related data and technology. For example, barcode, QR, and also about the reports and also some statistics for project management. These are some details that I would like to share with you. First of all is they try to look at different materials management processes. Then they define different types. You can see that some types, first of all, they define different workflow. They have the order, produce, shipping, delivery, install, and inspect. And then they find out that they have totally defined 7 types of different combinations of all these tasks. For example, order, produce, shipping, delivery, and then install. Some probably require loading, some probably require assembly, some probably require storage, etc. So with different combination, then you can see that they totally have 7 types of the material. And then they will assign this one to different material one by one. And after defining the material, the portfolio or the type, then they try to break down the project into different work packages, or it's called the work breakdown structure. And they also combine the different cases, and then all together they define different material types, and then link this one with the logistics, and then they can perform some kind of analysis. And they also look at the workflow. You can see that here they have the GC, general contractor, they have manufacturer, the mapper, and also the site worker. You can see that they clearly define who should be responsible for what, who should contribute the BIM model, who should contribute the information about the delivery, about the assembly information, about the inspection record, etc. And then based on this workflow, they have not achieved yet, but they are now they are working on is they will convert this one as the IDM format. If you remember, we talk about IDM. Basically, we have the workflow and also the exchange requirement. So once they define the workflow, then for each step, they define what's the exchange requirement. This is basically the concept of IDM. Then they also develop a logistics system based on this workflow. And you can see that they can capture the information of the project information, the notice, the resources, accounts, etc. And then they can perform different kinds of all these management system. And then they also can generate different status reporting, or they can have the dashboard, etc. And then they also can see the status by phase, by floor, by date, by status, etc. And then with that, they also support the mobile devices. That means maybe they can generate this kind of report daily. And then with mobile phone, then they already can get this information and then evaluate that daily performance and try to plan for the next day. And all this will be achieved by the BIM integrated information. And they also can link this one with the barcode, QR, RFID, etc. And then this is what they try to manage the construction accordingly. And something interesting is they also try to map the material information or map the material with the BIM object. And you can see that for this BIM object, then they have their own property set, and they need to define this information for each different kinds of materials ahead of time. And then they will fill in this information, and then they can link this one with the logistic status. And something I would like to share is here we talk about mapping the material information with BIM objects. And they try to define the BIM objects in 3 levels. One level is individual object. That means it's just a column or maybe a slab, something like that. One is the object group. That means maybe it's a group of the columns or a group of the fencing, etc. And then they also have the object called zone. And then based on the zone, basically like a room, something like that, then they can also manage. So then they can link this information to these 3 different levels of BIM objects. Then they can generate different kinds of report and dashboard. And you can see that they can regularly evaluate performance and see whether what they actually have performed is the same or better than the planned. If not, then probably they need to do something extra. And this is the dashboard view of the logistic status. And this is the BIM view of the logistic status. You can see that they generate their own, they try to develop a plugin by themselves, and they require a login on top of the ArchiCAD. And once they log in, then they will be able to get the project information. Then they can load the BIM model and also the corresponding material information. And they can also try to do filtering and then do different coloring. So something like this. So with that, then we can evaluate the performance of construction. And this one will be very helpful for us to know a potential problem ahead of time. After the construction, I would like to go through an example of asset management. And this is an interesting example that I would like to highlight. This is basically an airport project in Netherlands. This project basically they try to use BIM to support the operation and maintenance of the whole airport. And some background information is this airport is 100 years old in Netherlands, and this is actually one of the most important airline hubs in Europe. I don't know about right now, but at least it was the information last year. You can see that this is the BIM model of the airport. This is the BIM model using openBIM standard. They drew the BIM model, and later you will see that they also link the facility management information to different components to support the maintenance and also some searching. You can see that the model may not be very beautiful, but at least it's object-based, and then they have information for the major objects. And this is the essence of BIM-based facility management or asset management. What they are saying is, let's start at the end. That means they try to think from the user point of view. That means the facility manager point of view, to see how or what information they want the BIM model to contain. So that's why they also may not need a very fancy BIM model, but at least they need to first define what are the BIM models or what are the objects that they want to include in the BIM model. And for each object, they need to define the type and then also the attribute inside. Based on that, then they try to optimize the asset management. What they try to focus on is the data-driven approach. That means they will link this data with the data of similar components, and then they can compare. To do these kind of things, then that's why later you will see they pay a lot of effort to define the data structure. What they have in mind is, first of all, they don't only focus on the tools. They don't only focus on what software they use. They also focus on the process. They also focus on people, how they can support, how they can work together so that the whole workflow, they know what information will be required for each part, and then what tools, and all these will link together actually is to support the data. And with that, the ultimate goal is to make better decisions so that they can improve the business performance. Particularly here, the business performance is in terms of the asset management. Okay, but here I would like to focus on is what is important is the data. And then it's not only dependent on tools. Don't limit ourselves based on tools. We also need to think about the process and think about people. This is a case that they have presented, and I would like to share here is because they mentioned that for the current practice, the GIS platform, the facility management platform, and also the document management platform, they are isolated. Okay, maybe they use ID to link them, but still this one may have some problems. And also it's time consuming, and sometimes they have redundancy. So that's why they try to use BIM model to link all of them. What they try to build is a BIM as the digital asset twin or digital twin of the asset. Basically, is they try to generate what is very hot topic right now is common data environment. They try to build a common data environment for the built asset. And then they will link the 3D model, they link the sensor data, they link all these the staffing data, all those data into this CDE. And with that, then they can manage different parts or to support different applications. With that, then you can see that they have the CDE digital twin. They use the ID to link up all these different systems, like they have the IFC file. This one is the virtual model. They also have IFC messages. Later, I will talk about what is the messages. Then they also have the GIS model, which is a region scale model. They also link up IoT. They link up the Maximal FMM system. They link up the document management system, the electronic document management system, and also the incident data, and also they use SCADA to look at what's the system operation status. And this is something that will be helpful not only for airport, in fact. It is generic and can also be applied to other kinds of facilities, including buildings and also bridges, etc. What they have done is through Revit, then they develop a plugin, and then they mention Send IFC. That means in Revit, if they find out that after the inspection, they have some update on the BIM model, then after they have updated the BIM model, they click this Send IFC, then this IFC will be sent to the CDD, and then will be stored in the BIM server. And then later, you can see that this one is the old model, this one is the new model. You can see that they only have sent out they will update the model in the CDD, and then this one will make sure that the so-called as-is model, okay, or as-built or as-is model is always updated, because once they have inspection and find out there's some inconsistency, they change the BIM model and then send this one to this digital twin. Here, I would like to focus more on the dictionary. Earlier at the very beginning of today, we talked about dictionary. They did not specifically use bSDD, but the concept is very similar to bSDD, and then they create their own data dictionary for the airport. To support this one, you can see that they have the dictionary, they have all the terminologies for document, for property, for space, etc. And then for each object, then they have the definition, corresponding document, corresponding property and instruction, the function and location. And with all these attributes defined, then they will link with the rule, and then they try to use the standard like the IFC4, COBE, etc. And in the following, I would like to go through some more depth about how they define the data dictionary using the open standard. The concept is they have the digital airport and they have the data dictionary to support the access information on top of the CDE. So they call central data environment. And then they will support this one for the project team, and also they will link this one with the apps. This one may be a little bit technical. How they define the dictionary basically is not only a list of terms. They use a concept called the linked data. Linked data. So this linked data basically is they need to define this data, the subject, the object, and then the predicate. Okay, and then they will try to define and link all this information for each object. They have the attributes, but they also have the relationship between the objects. Okay, and this is what we call the linked data. Why they use this one? Because with linked data, it can be more shareable, it will be more linkable, extensible, and reusable. Meaning that, for example, for maybe airport, I have this linked data model. And then if I apply this one to building, some part can be reused, some part may not be relevant. Then I can just extract the relevant part and then for the building, and then further extend based on that as the skeleton. So this is what we can achieve based on the linked data approach. This one may be a little bit weird, okay, but I may not go to the details. But basically, the linked data approach means that they use IFC and then they use bSDD. They use IFC to define what are the entities. Okay, entities are this: the door or the element, the door. So all these boxes are the entity, and then they will link this one with the different object, and then they have the corresponding attribute. And then the attribute also have their own value as well. Okay, so this is the whole main concept. Okay, and now you also see the naming. They use colon. Colon means that this one is the domain, this one is the actual object. Okay, that means at the back end they also have different groups of the objects. Okay, so BSD is one group, and then like BSDD full is another group, something like that. And then with that, then they can link the file rating with the door. So you can see that they define the different attributes or information pieces of one object using the open standard like IFC, XML, RDF, etc. And this is what they have achieved. This is one example. They start with pier, and then they also have the airport position. What they have also established is not only they define what is the information inside pier and what's the information inside airplane position, they also link them and then say that, oh, has part, meaning that pier has part, and then part of the pier will have the airplane position. And the airplane position will have a marking. So that's why they have part, then marking is part of the position. Similarly, they define all these. So you can see that they don't only define the entities and also corresponding attribute. They also define the relationship between them. So you can see that for pier, then they have the bridge, the pier, then they have the pier building, etc. And then something like that. And something interesting is, for example, for road, then besides has part, which means it's a component, they also mention what is type, meaning that they will also define what is the type of that entity. And then this is the type of the entity road, and then road has a pavement. It means that this one should also have a pavement, okay? Because this one is a type of road, and road has a subcomponent pavement. So that's why this one should have a subcomponent pavement. So this is the whole concept of so-called the dictionary, okay? This one is only the backend, okay? The dirty part of the backend, okay? What the user will see basically is this user interface, okay? Based on the dictionary, they have something like this one for the asset. Then they will have the asset types, the properties, relations, documents, etc. And what support all these basically is that dictionary. For example, this one, they have a catalog. Then for this catalog, they will have the photos, they have the definition, the label, the corresponding the URL, etc. And all this, again, at the back end is actually the dictionary that they define. Okay. This one may be another technical, but for some of maybe advanced user, for some of you, then just for the information is that after they have defined the data dictionary in this kind of hierarchical system, they also allow searching of them. And to search them is not only keyword search. They also search according to this hierarchy. And that's why, for example, you can see this kind of hierarchy. They have the head, and then they have the binding, etc. And then basically they use the language called the SparkQL, okay? And they have the API. Basically, is with this one, then they define the ontology of that, and then they can do the searching more efficiently. Another interesting thing is they didn't only represent the object or the build asset themselves. They also support the action. Okay, that means they also have the event defined in the data model. Okay, you can see that, for example, they have lift or elevator, and then this one is linked to the transportation, etc. But they also link this one with the event. The event is, for example, they have a maintenance. Maybe this one is being operation, or this one is being cleaned. Okay, or this one is closed, or maybe some other things. So we also they also have the event, and then this event will become the trigger for this information. And then, for example, once I have an event, then they will link to the corresponding location or the components. So that's why with that, then the dictionary support not only the build model, but they also support the event management. So that's why this one is an event-driven or event-triggered. And once they have a corresponding event, then they will send out messages with the corresponding, they use IFC or it's an XML format of the IFC. Basically, they send out the messages of the IFC part that is relevant to the corresponding relevant parties. And then all this record will be stored in the database in the linked data format. So this is maybe a little bit messy. The message is basically they have the IFC different components. They have the asset name, they have the asset status, and then they have the corresponding the hyperlink. And then they send this one to the corresponding parties, and then all this will also be kept a record in the CDE. Then in the CDE, again, then what is I've shown was the backend, but this is actually what the user will see. Basically, it's a web platform that show us all the data stored in the CDE with all these transaction, communication, etc. So at the end, what they can see is this is a data in the GIS platform. This is data that can be shown in the FM system. You can see that all this data will be the single data, or we call single source of truth. Basically, it's the single data supported by the dictionary, and then can be populated in different systems. And then this one is the data in BIM. And all these, as I've shown earlier, they are in the openBIM standard, and that's why other software can also retrieve those information. And with that, then they can also show others like the real-time, where's the position of the fire extinguisher. So for example, if there's an accident, then they can see which are the closest fire extinguisher, and then they, in case there's fire, etc. Or they can also combine the leasing data to BIM model, and then they can also see, oh, maybe which area is more popular and more people will go, then maybe they will increase the leasing price, something like that. So this is the final situation of that airport in Netherlands. They have the ISO 19650 as the backend, and then they support the PIM, Project Information Model, and the Access Information Model, AIM. They use the information as the key, or data as the key, and then they capture the data and exchange the data using those open standards. And this is some, I think it's a good example for us to think about how this one can actually apply to our project. So I've spent quite some time on sharing some examples in terms of the use of openBIM for design, engineering, construction, and facility management. In the following, I would like to share with you some future developments just for the information, and then also some challenges in my mind. This one, I think many of you probably have seen many times. Okay, I remember I've been to a webinar, that I've been to a conference that I gave a talk, and then in this conference, I saw this picture twice in one day. But here, I want to show this one again, is that when we talk about full life cycle, we are not talking about only these design, engineering, construction, and the FMAM that I mentioned. In fact, if we go to the detail, there are more and more, okay, and then more applications. And so far, we have used BIM to support many applications throughout the whole life cycle. What we are now trying to do is we try to use openBIM to support that. Okay, why openBIM? Because if we look at the full life cycle, if you remember that zigzag diagram, we want to use openBIM so that we don't have so much information loss from one stage to another stage. And in the following, I will just, due to the interest of time, I will just give you some example of the openBIM applications for different parts of the life cycle. These are the ongoing work that are not so mature, but just let you know ahead of time, because sooner or later, then they become mature and then will become available for us to really use in practice. One is, in fact, for buildingSMART, some people are developing this IDM and MVT for fire safety engineering. What they have done basically is first define the workflow, and then based on the workflow, then they try to define what is the information requirement for different tasks for fire safety engineering. For example, simulation or evacuation, etc. So they define all these requirements. Also reference to the local requirements. At the same time, they also define the MVD. That means for BIM model, which part of the BIM model will be needed to support the fire safety simulation. So we don't need the full model, so only part of that. Another example to share is Quantity Takeoff. Actually, the buildingSMART Denmark is developing a project trying to use openBIM to support QTO. They basically try to list out the elements and the associated quantities, and then basically they try to generate a BIM model so that they can calculate the required quantities. And then they also try to generate or develop an MVD for the taking off. And this MVD will be based on IFC 4, and then will be related to the design transfer view. With this, then you can, this one example that they have a IFC column. And for the IFC column, they define attributes like IFC quantity set, and then IFC element quantity, IFC physical quantity, etc. But how to define this one? They need to refer to the local rules of measurement. So in Hong Kong, we have the SMM, okay, and the standard method of measurement. In Denmark, they have their own. This is one example. How they look like is, for example, for a column, for different shape of the column, then how they do the measurement, and then what are the attributes they will refer to. Now this one actually is not in English, but basically you can tell they are trying to do the length, the volume, the diameter, something like that. And for example, for column and slab, then they also have different ways to consider the volume, okay, or different dimensions like the length. So this is actually for Quantity Takeoff, maybe it's not that simple, frankly speaking, because for different geometry, we need to consider the special cases. But this is actually the thing that's why they are developing. And now is the openBIM for QTO. They are also developing IDM. And if you remember, IDM actually has two components, workflow and exchange requirement. So this is the workflow that they develop for preparing QTO. So from start, and then they evaluate the QTO, and then the base quantity, stuff like that. And then they also have the IDM, the workflow for performing the QTO. Okay, I don't go to details. And then they also have the information exchange requirement, okay, for the IDM. That means for doing the QTO, what are the information required to exchange, to capture? For example, the element, the space, the story, the building, etc. So this is what they try to define and then embed this one to the workflow to create the IDM. Third example is actually some of my team's work about openBIM for Rebar Prefabrication. Basically, this one is we are very fortunate to get the support of CIC, and then is our CIC research project, which will end end of this year. We will also have a relevant webinar soon this Friday. So there are two parts. One is about using BIM for design, rebar design. One is using BIM for rebar fabrication. And here I would like to focus on the prefabrication because this one is relevant to openBIM. So this is something that we are trying to do is based on BIM model. Then we try to generate the rebar fabrication machine code. And this one is called the BVBS. Okay, it's in German. We try to compare what are the IFC components to represent rebar, and then what is the information required for BVBS to cut the rebar and bend the rebar. So then after trying to compare the different components and information, we found that the red color basically is the information that we found lacking, missing. Okay, and this is the IFC extension that we are proposing and still developing. But this is something advancement on the existing IFC. Hopefully, we can support the rebar prefabrication. And then this one can also do the auto generation of the BVBS based on that. From Revit to IFC through Dynamo, then we can get the BVBS. The last example about future work is soon you will see the integration not only for buildings, but also infrastructure and the urban environment. So you can see buildingSMART is also looking at the integration of BIM and also GIS because particularly for the FM or for the airport example that I've gone through, you can see that they require both BIM and GIS. And earlier, we have worked on the integration of BIM, particularly IFC and CTGML in the schema level to combine the data or the transfer the data from IFC to CTGML and from CTGML to IFC. Okay, but in fact, what the community is already looking at is how to integrate IFC with CTGML and also with the land infrastructure. So basically, the IFC is from buildingSMART, and then the CTGML and land infra is from OGC. So they try to see the built environment or built asset environment as a whole, and this is also the main theme of this alliance is that we look at the built environment as a whole and then how they can be integrated. So stay tuned, and then there are more development in the near future. Then I've mentioned many ongoing work, completed work. In the following, then I will mention actually what doesn't work. Okay, not every piece, not everything actually will work. There's still something that we need to work hard and solve. When we work on openBIM, I know that some people will have the concern that I don't have the software. Okay, I don't have the software for supporting openBIM, or maybe if I use openBIM and the software may have some information loss, etc. And I found that the software, some software may interpret the IFC data models differently. For example, different software that export IFC, those IFC are not identical. Okay, the same building, but when they generate IFC, they're different. Okay, and also many times, sometimes this software may not consider full set of the openBIM standard. For example, we talk about BCF, we talk about NBD. Some software don't have this concept. Okay, and also, frankly speaking, there's so many software. Okay, of course, there's some major ones, but there's so many openBIM software. Which one is better? Okay, any certification or IFC extension. I've mentioned some people try to extend the IFC, but the software may not support those. Second challenge, I will talk about 4 challenges. Second challenge is the IFC entities. IFC has been developed for more than 2 decades, but it's quite mature for buildings. But for infrastructure, like airports, they have mentioned that it's not comprehensive. Particularly, there's some missing IFC entities. They don't have like the taxiway, the apron, etc. In the IFC data model. And we are only talking about IFC model, IFC, right? So we also have the MVD, IDM, bSDD. Okay, many of these other types, non-building type of the infrastructure, they don't have the relevant MVD, IDM, bSDD. So this is something that we still need to develop. And you also see that not only about airport, they also have the rail, they also have the road, ports, bridges, etc. So that's why this is we look forward to the next phase of IFC, which is IFC 5. Then they will touch on all this. Number 3 is we should consider the full set of the tools. Okay, note that why we have so many open standards basically is for communication. Okay, but for communication, they actually have different purposes. We shouldn't only capture the digital model using IFC, and it's not enough. This one is only one part. But for example, for communication, we still need BCF. For the terminology, we still need bSDD, something like that. For workflow, we still need IDM, MVD. So this is something that we need to think about. The last is we need to consider the holistic thinking. Okay, many times we only try to use BIM for a particular task, particular project. For example, we just use BIM for 4D, and then BIM for structural analysis, I mean use another software. BIM for solar analysis, I use another software. So all these are very isolated. So this is what we call is little BIM, isolated. Okay, and what we want to achieve is a big BIM. Big BIM means that it's a single BIM model, and then it can fit many different purposes of the project. And then this is what we hope to achieve is a big open BIM. Use open BIM standard so that we consider the whole infrastructure, not only a particular building, particular component, or particular task as an individual. And so I have mentioned all the challenges, etc. There's one more thing, and actually one more slide. Okay, there's one more thing. Many of you probably know that I come from university. There's one, I don't know whether you have heard of 孙子. Okay, 孙子. In Chinese, they say that 不文不曰文之，文之不曰憲之，憲之不曰知之，知之不曰行之. So what it means is that if you don't know, try to hear, try to be open-minded. Okay, try to listen more, and then if you hear, you may forget. Okay, if you see, then you will remember. But if you really understand, do it. Okay, if you really want to understand, do it. So that's why I know that in the industry or in many people that have many concern about open BIM, but sometimes we need to have the leap of faith. And as this logo have shown, just do it. Okay, I hope that this presentation have shown you different examples of how people use open BIM, and this one will give insight. And maybe there's some problems we have not solved, but together then we can just do it and then can solve those problems, and then we can use open BIM into the next level. So this is what I want to share today, and thank you all for your for listening, and thanks again for the opportunity for me to share here. Okay.
Thank you, Dr. Jack. It was a very inspiring lecture. Now let's move on to a Q&A session. Please feel free to type your question in the Q&A box. Dr. Jack will answer you.
So if you have any questions, please type in the Q&A area, and we will pass to Dr. Jack Cheng. So do you have any questions for Jack? Okay, so Jack, we have one question. What is the major difference between using a BIM software against the use of openBIM?
Good question. So look that openBIM is not only software, as we have mentioned. openBIM is also about is a toolkit. Of course, we use software to realize this one, to have the B model, etc. But it's also about our thinking. That means we need to define the information. We need to try to link up the data. Okay, plan the workflow ahead of time, etc. So this is actually the openBIM mindset. Okay, but to realize this openBIM, of course, sometimes like the BCF or the maybe Kobe or maybe the IFC, etc. We need software support like those common names like Revit, ArchiCAD, etc. So, but I think just the visualization itself, then we use software. Okay. But we sometimes may need to think beyond the scope. Okay, as I've demonstrated in the airport case, they not only have the data visualized in different systems, like the FM system, the BIM system, etc., but also they at the back end they actually have more detailed things behind the scene.
And also, we got a question about what is the role of mapper at Japan case?
What is the role of
mapper? M-A-P-P-E-R.
Okay, so M-A-P-P. Oh, okay. Mapper. Mapper is trying to map the information. That means from the holistic point of view and then the detailed operation. That means maybe for airport, they need to look at the whole region, but at the same time, they need to see the detailed building level, something like that.
Okay, and then another question is, are Autodesk tools more suitable for openBIM?
I think so. There are several software, and I think Revit is one of them. What is good about Revit? I don't want to sell any particular software here. It's a little bit sensitive, but I think one good thing about Revit is many people develop different plugins. And through plugins like Kobe, they have Kobe plugin, they have the BCF plugin, etc., and then they can achieve different openBIM application and also some automation, etc. So I think it's actually fascinating.
Okay, and then another question is, what is the difference between openBIM and digital twin?
Good question. Digital twin is the concept of the digital representation and link with different information. Okay, it does not necessarily be using openBIM. Okay, it can just use just one software, or maybe they just use one standard. Okay, but openBIM means that they have the information that can be opened by different parties, can be shared by different parties. Okay, so what I think it may be a little bit confusing in the airport case is that they use openBIM to realize the digital twin, but the openBIM is only the method, the tools. But the digital twin is actually the digital representation linked with different information. Okay.
Okay, and another question is, what is the major difficulty we are facing in Hong Kong? Maybe we can say it's about financial support. So do you have any suggestions?
In Hong Kong, I think it's already quite fortunate, and I have seen other countries. particularly in recent years, because the government made BIM as compulsory for all its public project exceeding 30 million Hong Kong dollars, and then we have the momentum, and we also have the CITF. We also have CIC to support in different aspects. So I think it's already quite good compared to many other countries. But of course, it can be even better. And also, frankly speaking, Hong Kong is still relatively small. And compared to like China, mainland China, I think first, of course, we need to have some good mindset and then some open mindset. But at the same time, we also should have enough project for us to try, for us to see, to evaluate. Then this one will be better. And this sense, I hope we can have it, or maybe we can have a broader scope to, and a broader horizon, including like mainland China or like at least the Greater Bay Area.
Okay, and another question, and he or she is a facility management practitioner, and can you share some ideas? Oops. Wait. Okay. Another question first. Okay. So, what is your view in adopting openBIM while different clients have their own security concerns?
Other plans have security concerns. In fact, I didn't share here. I agree security is one issue, but this one doesn't mean openBIM is not suitable. So openBIM is only the format, and for security, no matter what format, I can still encode it or I can still hack it. Okay, just that maybe if I use proprietary format, then it seems more secure. You cannot open it with all kinds of software. But the thing is, once you know which software, then you can still get the information inside. So I agree from security point of view, it seems it's not as secure as proprietary format. But at the same time, for openBIM, the concept is collaboration. And for security, we can enhance this one using another technologies, like maybe blockchain or others, encryption, etc. But openBIM has its own advantages.
Okay. This question is about while formulating AIMCDE, how should openBIM be considered holistically?
When we try to formulate the AIMCDE, how CDE, sorry, may you?
For more information from this, another question first. Okay, so I want to ask how to unify the software companies and standard. Would a big mega company or global organization with country representative may help?
Of course, I think that the companies, the bigger companies, of course, they have better support, but I think technical support is important. They have local support, of course, is good, more responsive. But I think even though they don't have local support, doesn't mean that they're not responsive. Okay, it really depends on the company culture, I would say. And sometimes also, I think it really depends on particular software, particular company. I wouldn't say that big or small, which one is better. Sorry, I probably cannot comment on this because it's very it's not universal, I would say.
Okay, so what scale of development project is most suitable to adopt openBIM in view of cost effectiveness?
By the way, can you please share the question to published? Then I can take a look. Yeah. So sorry, can you repeat the question?
Okay, another first. Okay, so okay, what are the issues with industry players accepting openBIM? Okay, I think probably Kevin, are you controlling the panel? Okay, and another question first. Okay, so what is the cost effectiveness of using openBIM? Any statistics of projects in Hong Kong or other parts of the world? Thank you.
Good question. I remember a few years ago, then maybe even right now, I've heard similar question. Actually, not openBIM, it's BIM. People say that now we use openBIM, it should save cost, but how comes I need additional money to use BIM and budget this one in the project? So I think sometimes it's difficult to say. And for openBIM, of course, there are some case studies saying the benefits of openBIM, but at the same time, there are also some potential problems of openBIM. I haven't seen a very well recognized statistics or study on measuring the value of openBIM. This one probably we can consider that. And frankly speaking, you can see many cases that are shared are not in Hong Kong. And that's why I think it is the purpose of us to share with all of you about what is openBIM, and hopefully we have more openBIM projects in Hong Kong. And without quantity, we don't have quality.
Okay, so due to the time limits, I think we have to pick the last question. And Jack, can you see the last question in the published
You mean
area?
Okay, you mean what is the cost effectiveness?
Yeah. And what is the issues with industry players accepting openBIM for projects?
Okay, what are the issues with industry players accepting openBIM? What are the issues? Okay, these are similar to what I have shared about the 4 challenges. Many times, I think they have difficulty to select the software, and also they may not have enough understanding. They also may think that for our industry it's interesting that, for example, we cannot make mistakes, because making mistakes is very costly in our industry. It's different from like manufacturing. They can make a prototype, and then if wrong, then they can do it again. So that's why we are very cautious when we try to change or switch to another approach. And this is also, I can understand the issue, but that's why I would suggest that it's better to start with maybe a sub-scope, or maybe we can work in parallel. That means we can still use the current approach. At the same time, we can use openBIM in parallel, and then it will not affect others, but at least we have the openBIM experience.
Okay, and one more question is, which kind of file format should be exported from ArchiCAD for other disciplines who need to see the detail of each object?
I think IFC can do that, but I also heard the limitation. And that's why sometimes my experience is we need to modify the IFC after, it depends on the application. Common application, IFC will suffice. But for some special application, we found that we cannot export those internal information to the IFC to other software. So that's why we need to extract them using other means.
Okay, thanks very much, Dr. Jack Chang. And now
thank you.
Back to MC Wendy. Thank you.
Thank you, Dr. Jack and Wendy. Thank you everyone for joining today the training class. Remember, next time we will have the 4th session, Mastering Knowledge and Tools for openBIM. The speaker is Kelvin Wong. The date is 27. The date is 10th of June. So if anyone needs the CPD certificate, please access the website link to apply for it. Sorry that we cannot answer all the questions in the Q&A because of the time limit. We will
we are hungry.
We will answer the rest of the question afterwards, or in the next time the session will go back to this question for your more understanding. Thank you, everyone.
Okay, thanks again for joining. Thank you.
Thank you. Bye-bye.